Welcome to ordered selections with identical elements. So this is a continuation of our permutations where we use factorials because the numbers diminished as we went along. But this time, whereas in before we had no repetition of letters or numbers, these sets will now have that repetition. So we may end up with 3 A's or 5 7's, or in the case of the word Mississippi, where there are 11 letters, if all 11 were different, we would be able to have 39,916,800 different word combinations. But the fact that there's 4 S's, 4 I's and 2 P's, each S can be interchanged with itself, as well as each of the I's can be interchanged with each I and the P's with each P. So that means we've overcounted the number of S's by 4 factorial, the number of I's by 4 factorial, and the number of P's by 2 factorial. And so our total unique words are 11 factorial over 4 factorial times 4 factorial times 2 factorial, and reduces down to only a possible of 34,650. So let's have a look at a example. Or a second example in a sense. So we've got the word differentiate, and it's going to be arranged in a straight line. We're going to find the number of unique arrangements, and then we're going to have a look at what happens when we have the E's together. So the number of letters there are 13. We happen to have 2 I's, 2 F's, 2 T's, and 3 E's. So the number of unique words is 13 factorial over 2 factorial by 2 factorial by 2 factorial by 3 factorial. So that's 129,729,600. So what about if we have the E's together? Well, similar to what we did in the last video where we grouped together, we're going to group them, but because they're all E's, we just leave them as that one group and treat them as just one. So, and then we're going to combine them with the other 10 letters. Now, the other 10 letters can still have that repetition or the identical elements of 2 F's, 2 I's, and 2 T's. So we've got to take those into account. So we've got 11 to choose from because the 3 E's are going to be grouped as one, as well as the other 10. So with those 2 I's, 2 F's, and 2 T's to keep in mind, out of 11 letters, that gives us 11 factorial over 2 factorial by 2 factorial by 2 factorial, which is 4,989,600. Thank you.